This is Mr. Gillum, and today we are going to review some vocabulary before we start getting into today's unit. And we had those questions about key features that we kind of just ignored for a while, or extra key features that might be important, but now we're going to learn a few of them today. All right, a relative maximum. That's the first thing we want to talk about, a relative maximum. So find something that you can highlight your graph with, maybe. A relative maximum is basically a maximum that's in that area, and a maximum that sounds like the most, right? Well, we're looking for the highest point on the graph in that area, okay? A lot of times it's where it changes direction, okay? Or it changes direction from increasing to decreasing, all right? So there's a couple relative maximums here. Well, actually, there's just one. Point C, right there. Point C is a relative maximum. That guy right there. Okay, he's the highest point on the graph in that area. It goes from increasing to decreasing on that spot. Okay, so we call him a relative maximum. See how he's the highest part of that graph right there in that area. A relative minimum is the lowest part of a graph in an area, where the graph goes from decreasing to increasing. So right here, this little fella. Now, sometimes people want to put where it crosses the x-axis. That's not the case. Okay, relative minimum is just the lowest part in that area. A relative minimum. So point G would be a relative minimum. An x-intercept is, of course, looking at the x-axis, where it crosses the x-axis. So we have an x-intercept at B, at F, and at H. Okay, so 3 x-intercepts, V, F, and H. All right. And we have the y-intercept, where the graph crosses the y-axis, or the vertical axis. So remember, this is the y-axis. Looks like we only have one y-intercept. And I'll tell you something about the y-intercept. If it is a function, there will only be one y-intercept, because it has to pass the vertical line test. And if there was more than one y-intercept, it wouldn't be passing the vertical line test. And a maximum. We're going to change this to absolute maximum. Absolute maximum. And an absolute maximum is the highest point anywhere on the graph. So in this case, we can't really tell where the highest point is because it goes up forever. So there's no specific absolute maximum. However, if we change this to just a closed point right there, and we'll call him point Z. Okay, if I change it to point Z right there, then point Z would be the highest point on the entire graph, the largest point. So anywhere on the graph, C would not be a maximum, an absolute maximum. It would just be a relative maximum. And finally, a minimum. All right, and same thing. I see that when I'm looking up and down, this graph is going to go on forever because it got an arrow on it. However, to illustrate my point here, I'm going to change that to a closed point on A. This is going to be a closed point right there. And now it is the lowest point on the entire graph. We're not going to call that point A, we're going to call it point Y. Point Y. So point Y, if it's actually a point, not a line, or not a continuous arrow, that would be the absolute minimum, the one lowest point on the entire graph. Okay, if we were looking for the absolute minimum and it was an arrow, it would be undefined. We wouldn't know exactly what the absolute minimum was, or it would go towards the direction of negative infinity, but we wouldn't actually be able to tell. So that's some key vocabulary that you're going to need to know, and we've talked about intervals before. So that's it for today.